My name is Greg Hanson. I'm the CTO and the VP for all our specialist organizations across EMEA and Latin America. My Twitter handle is on the bottom. So if you like some of the things that you see today while I'm presenting, please do subscribe or join me on Twitter and you can get more feeds going through. These days it's always a good illustration of whether people have listened and whether people like what you're saying. So it'll be a good evaluation of my presentation. So I'm here to talk to you about the hardest part of AI. And the hardest part of AI is often, it's to do with the data management and making sure we can really produce high quality data assets that we can really get the type of value that we want to get from our data, which we probably haven't realized so far. So I'll take you through some of the concepts and hopefully you can see how we potentially can help you. One of the first big problems that we have with trying to understand and get value from our data is it's getting more challenging to get value from data. Why is it getting more challenging? Well, first and foremost, we're seeing an explosion in the amount of data volumes. There's 15.3 zettabytes in data set and traffic, and as you'll know, it's doubling on a constant basis. So it's really difficult to manage just purely the volume of data. And then within the organizations that we work in, our own organization included, we're seeing new users who are clamoring for data. So these are not just data scientists or data engineers. These are tech-savvy line of business owners, line of business individuals who want data to make a material impact to their day-to-day job and how they interact with customers and suppliers that they work with. And that number is 500 million and growing on a daily basis. In a new world of customer experience where we want to make sure we've got personalized experiences for everyone, it's important that we can encapsulate all data types, so we'll get a much more rounded view of Greg. So we can personalize and set our personalization engines up to make better results. And that will often mean that we need to integrate various different types of data, some of which are inside of our organization, some of which might be external to our organization, like social media, for example. And increasingly, we'll have to integrate machine data, IoT data, data from devices as well. And that will mean that almost 20 billion or 50 billion, depending on the survey that you look at, you'll need to integrate data from a rapidly increasing amount of machine data, which will further add to that explosion in volume. And increasingly, all the data that we want to analyze is increasingly cloud-based as well. At the moment, over 92% of data traffic will come from the cloud. It's predicted in 2020. But let's not forget all the data that we still have on-prem. 60% of organizations will still have a large amount of on-prem systems by 2025. If you put all these challenges together from left to right, it's clear that as humans alone, we're going to find it very difficult to do this in the modern digital era that we live in. So we're going to increasingly need to use artificial intelligence in order to leverage the data assets that we have at our disposal. And one of the things I'll talk to you about is how AI can shift, not just from what I call in the consumptive end, but also in terms of how you build high quality data assets. Because what many organizations fail to do is, many organizations focus purely on the AI outputs, on the consumptive side. So I'm looking at what data can provide me, what comes out of my machine learning engines, what visualization I've got of my data. That's what I call the data outputs. But what about your data inputs? We'll talk about how important it is to make sure that your data inputs are extremely high quality, so you'll get the best value of your data outputs. Well, the only other concepts that I wanted to go through as well is, if you think about many organizations 5-10 years ago did not have data scientists within the organization. I think we're now reaching a maturity curve where many large organizations have invested in a chief data officer or a chief digital officer. And a natural extension of that often is a data team that can really start to drive the value of data. And that initially or commonly is an investment in data scientists. Okay? So we're seeing that. If you follow your sort of physiology and your psychology, you might be familiar with Maslow's hierarchy of needs, where it talks about a pyramid of how humans, what their basic needs are, going up the pyramid in terms of how they feel more supported. And this is a take on that, which is to do with data scientists. And it talks about at a base level, our data scientists require access to data, instrumental, generated content. Then we need a reliable data flow. Then we need high quality assets, and so on and so on and so on and so on, until we get to the top of the pyramids. But ask yourself this question: are the data scientists that we have, if you're a data scientist yourself, you may suffer from the fact that you're not doing much science. What you're doing is a lot of data acquisition, a lot of data preparation, a lot of data cleansing, and you're not doing much science. One of the nice statistics that I saw at our organization's Informatica is one of our tour events in London this year. We had Neil McIver, who's the chief statistician and CDO for the Department of Education. And he said that he has a team of data scientists, and 90% of that data scientist team was spent acquiring data. Of the remaining 10%, 90% of the 10% was spent fixing that data that they acquired. So only 10% of 10% was actually what they wanted to do in their job as a data scientist, to create value from data by providing insight. I would argue that a data scientist shouldn't be doing all these things. And now we're starting to see, with that maturity of evolution, that we're starting to see new roles come into our organizations to support this. Data scientists should focus on the top of the pyramid. And then in terms of the data management layer, in terms of creating high quality assets, that should be the role of data engineering. So within your organizations, you'll see many organizations have reached that maturity where they have a data engineering team and they have a data science team. They're different people, different characteristics, different skill sets, and different education in order to be able to do that. Fundamentally different people. The reason why this is so important is if you don't have an investment in generating high quality data, how can you trust the output of your AI? We've all gone and all seen stories of how biased data sets or incomplete data sets, I think my microphone has just dropped up. So biased data sets or incomplete data sets have really generated some catastrophically bad insights in data that businesses have made decisions on. And often what you'll find in this reality is there is no silver bullet in AI. You need to invest in AI, and therefore you need to invest in your data quality and your data management in order to make sure that you're realizing the benefits of AI. What often happens with many organizations is they make decisions based on AI with a higher trust, but actually it's flawed because the data that they're making decisions on is poor quality. To the point here, James Ovenden talks about mistakes in the training data pollutes all the results, makes any insights untrustworthy. And the reality is now we've reached the point where it's clear that we not only need AI to provide us with analytical processing, to take high quality consumable and governance to generate that vision, we also need AI in the back end to make sure that we're generating the pristine data that's required for high quality machine learning and better analytical insights. And actually, if you think about the role description for data engineer and data scientist, it becomes clear where their focus areas are. Because quite simply, if we don't have AI in the back end, it's garbage in, garbage out, or in the UK, rubbish in, rubbish out. You can't trust the results that we've got. So what are the typical challenges that we've got with trying to make sure we've got high quality data? Well, typically, you'll see this sort of trend. You'll see, how do I even get data to my cloud data lake? And increasingly, data lakes are cloud-based. Where is the data I need to drive my AI? How can I make disparate data types work together to fuse them? How can I ensure that I've got pristine data assets? And how can I include AI in my workflows to take account of extremely high volumes or changes that otherwise I would need to spot, amend, and retest myself manually? And how do I keep track of all the data that's propagating through to make sure my insight is correct? One big challenge that I see when we do these data science type exercises is, how do we replicate what someone's done in a prototype and put it into production? Often you can't find the lineage or heritage of what's happened to data in order to be able to productionize that. So if you can do that in a high quality data management area with AI built in, you're going to have a much better track record in terms of being able to generate high quality outcomes. Now here at Informatica, my own company, we talk about the use of AI to help in that data engineering layer. And here's how AI not only can influence the outcome, but can also influence the preparation of all that data to give you those pristine assets. We can use AI based upon metadata. So the secret sauce here is metadata about data. We will analyze and build catalogs of metadata. And I think organizations really need to invest in those enterprise metadata catalogs. When you have a metadata catalog, you can start to use AI on top of that purely for the principles of data management. You can start to automatically look at data similarity, so matching data types against one another to see whether or not data is relevant and should be included in a particular prototype or machine learning. You can help to use AI to automatically build a catalog by scanning data, using AI to then tag, classify, index, and store the data about that data, giving you a searchable archive of all your data assets. Remember, one of the first key problems that scientists or engineers have is, where is my data? If you've got AI building a catalog with a searchable archive of data, that is a phenomenally powerful tool. If you've got AI, you can also make intelligent data recommendations to further increase the cleanliness or format of data. For example, simple things like name and address cleansing, simple things like governance of data. You might have a standard for product within your organization that you want to make sure that entities are standardized. All those types of rules become reusable, and in an AI focused on data management get deployed automatically with recommendations for data engineers to use those to maintain standards and increase high quality assets. And then things like anomaly detections as well. So errant data, poor quality data. Should I feed this data into the pipeline for my prototype or not? Have I assessed the bias of this data as well? These are types of things that the AI framework can help with. And one of the things that we've worked on as well is to try and make some of the repetitive tasks go away. So one of the common things that you have to do when you're sort of removing bias from data sets is to do what we call one-hot encoding. Okay, so where you've got to take a data set and then build like a normalized set of data. So there's no bias built into the machine learning area. Why do we have to do that ourselves? Could we not automate that? And you can, with AI built into that data management and engineering layer. We have that type of encoding that can work for common things like gender, for example, or locations, and so on and so on. So how should we expect AI to help our people within the organizations we work with? Well, first of all, if we look at the types of roles that we've got within our organization, here you can see the type of people engaged in leveraging data. First of all, the data engineer. The data engineer can use a catalog to find information, but wouldn't it be nice if the AI deployed in data management can map that information automatically and dynamically? And you can do that when you've got AI built into the data engineering layer. This is what we call intelligent data discovery. You point it at a raw source of data, it will interpret the data, it will categorize the data, and it will parse the data and map the data to a chosen target format automatically for you. That saves many man-years of efforts, and that's what organizations need to do to improve productivity. To improve the trust of data, what we really need is a tool set built upon the same foundation that can offer dashboards of data quality. So we're constantly assessing where we started from, our baseline. We're building some rules associated to what data quality for a person, a product, a location, a store, an asset should look like. And then we're measuring against that over time to make sure we've got a constant stream of high quality data. And then in the data scientist area, where is my data? Well, if you use that AI in data management to help build a metadata catalog, it will give you what I call the Google for enterprise data assets. You can have a screen like this that will enable you to search for the type of data that you want as a data scientist to be engaged in your prototyping exercise or your scientific study. And here you can see how you can use AI to automatically match data together to provide links in data that you might want to consider to also include in your prototype or your study. One of the common links that's broken right now is okay, we can find our data. What do we then do with our data? The data scientists will still need to probably merge some data with an external source of data or a third-party reference data like weather data, for example, that might be of interest for this particular study. So they'll still need some form of transformative tools, be it code-based or Excel or whatever people are using. So what's interesting here is, why not have a tool that's built upon the same framework, using the same AI rules, but to be deployed for the data scientists as well, in capabilities which we call data preparation, to give them the tools and the same AI framework to recommend a rule that needs to deploy to either govern data, obfuscate data, cleanse data, merge data, match data, all that AI leverage within this sort of canvas that you've got here. And it looks and designs and feels like an Excel, for example. But what's sitting behind that, one of the key things about AI is it's storing every interaction with the data. So once you then publish that to a visualization tool like Tableau or Qlik or MicroStrategy, which you could do within a tool set like this, it's then keeping an audit of all those changes. So when you come to productionize what you've done, if you like the output and you make a decision, you can very rapidly take that recipe and then productionize that into the operational data management and the processes that you have. And in increasingly governed legislative frameworks that we live in, we need to understand the flow of data between all these different roles within our organizations and how we're leveraging data. Not just for GDPR purposes, but for many other legislative frameworks around highly regulated industries. And once you use or adopt a metadata-based principle with AI built in, that sort of catalog of information that you built to help search for the data scientist also becomes a great way of understanding how data propagates through an organization. So you can leverage things like lineage diagrams that you see here, where you can actually see the original origin of a piece of data that went into a study. And then you can drill down into that to see every single transformation that was applied to that piece of data across all these rows to get to the final output, okay? So that's a step change in terms of increasing the accuracy of data going into our data science studies. And the reason why this is important is because truly with this we can make a big insight. So one of the organizations that we've worked with is a company called MD Anderson in the States. They're a cancer hospital. And I'm sure you've heard many stories like this, but I like this one because one of the things that they worked on is trying to make sure that with this type of model in place, they could try and make a difference to cancer treatments. And one of the things they found is they identified a type of breast cancer. And once they studied all the biopsy data associated to that, they actually identified that they didn't just have one type of cancer, they had 7 types of cancer that they needed to treat. So immediately you're kind of thinking, well, we should treat those different strains of that same cancer in different ways. Then we overlay using DNA data, and we actually recognize that we've got protein links in DNA between different types of cancers and different effects in protein DNA. So then you start to get to the personalization of treatments. So now an individual with a certain type of DNA and a certain strain, one of those 7 strains, gets a personalized prescription associated to that, which further increases the outcomes. Now that was only possible because we were able to make sure that all those roles collaborated together. We had, first of all, data engineers making sure that we had complete data sets around the biopsy data and the DNA data and processing that at scale and taking out any errors in data that were obvious to be seen. Then again, we had data stewards who had those types of screens who could analyze that data over time and make sure that data was as pristine on day 30 in the trials that it was on day 1 in the trials. And then you've had data scientists allowing the tools to then merge those data sets together, push them into the AI engine to get that visualization and links between the DNA and the types of different cancers that we talked about. So it's transformative if you've got this type of framework to really accelerate your insight in data and get higher quality results, but high quality results that you trust. So now you're going to make decisions based upon higher probability that you trust, based upon a higher accuracy of data. Right now, many of us in this audience, we're probably making decisions, but you don't know whether we're making decisions on a high and pristine source of data that's going into our trials. So, takeaways I'd like you to think about as we move from this room is I think you need to think about how you consider the investment in data engineering layer. If you don't already have data engineers in your organization, you've just got data scientists, think about maybe as a maturity, as a next step, we should start to invest in data engineering principles to make sure we've got a chance of generating those pristine assets, and we're getting the data scientists to focus on what they should be doing. In this world of multiple hybrid clouds on-premise and so on, the recommendation from organizations like Gartner, for example, is to standardize on technology. There's so many different skill sets across so many different clouds and applications that actually you need to standardize on one data management framework to make sure that you can do things in an agile manner. Personally, I think a metadata catalog is key. Without that metadata catalog, how do you know where all your data is? And if you can use AI to very quickly build that metadata catalog and maintain it, all the better. Many organizations right now are using people to build documentation around data. That's just not going to scale. You need AI to do that for you. You need to build trust. And building trust means not only having assets, enterprise assets in that catalog that you can prove the quality of data against organizational standards, but you can also get greater insight into what's happened to that data, what transformation it's gone through, and how it's been governed in the lifespan of that data. And that becomes key to then making sure that you've got a higher probability trust rating in the decisions that you're making. And then finally, how to accelerate that journey. Well, give the tools to the people who need it, get the data scientists focusing on the science element, and then use those type of data preparation technologies on the same platform and foundation because you've standardized. And you'll really be able to put those recipes of how those prototypes and AI machine learning algorithms have been put into place. And then you can quite rapidly productionize them because you know exactly what's happened in order to move them into production. So that was a summary from me. I think I've probably got a couple of minutes for questions before we close down. But if you were interested in what I had to say, as I mentioned, I am on Twitter. My Twitter handle is @HansonGJ. So if you want to know more about what I think in the industry or what Informatica, the organization I work for, is doing, then please join me on Twitter and I'd be happy to keep pushing data to you. Any questions in the audience that we want to take before we close down? Okay, thanks for listening, thanks for coming, and we have a stand at the back of the room there on the left-hand side. Thank you.